Let's graph a quadratic function together. So here we have our quadratic function as well as the quadratic equation. So the first thing we want to know is, does this function open upward or downward? So it's in standard form. The coefficient on the leading term is a equals -4. The coefficient on x is -24, so b equals -24. C is -32. We won't need that. Because a is negative, then our parabola is going to open downward. We'll have the vertex sitting up here on top and the axis of symmetry, cutting the parabola symmetrically in half. So that answers a couple of our questions. Does the parabola open upward or downward? Because a is -4, it's downward. Part C, is this vertex a maximum or minimum? Again, because it opens downward, the vertex is sitting on the top at a maximum position. So part C, the vertex is a maximum. Now they want us to actually find the vertex. X equals -b over 2 times a. That's the x value of the vertex, and we'll have to find the y value. Because the vertex is sitting on the axis of symmetry, this also is the equation for the axis of symmetry. So this is the axis of symmetry equation. So when we find x, we'll have that equation for the axis of symmetry. So -b means the opposite of b. Negative times -24 is a positive 24. 2 times a, 2 times -4. It's going to give us 8. 24 over -8 is -3. Now, we're already going to write the answer to the axis of symmetry. X equals -3. Part F, axis of symmetry, x equals -3. Okay, so let's find our corresponding y value for the vertex. So when x is 3, find y. When x is 3, find y. So let's substitute -3 in for x. Okay, so we're going to have -4 times 9. -24 times -3 is positive 72. -36 plus 72 minus 32. 72 minus 36 is 36. Subtract 32 from it and we get 4. So the x value is -3 and the y value of the vertex is positive 4. So we go and answer that part of the question. Part B, the vertex is -3, 4. Okay. Next we want to find the y and x intercepts. So y-intercept and x-intercept. Now the y-intercept, let x equal 0 and solve for the matching y. For the x-intercept, we're going to do the opposite. We will have some x value and let y equal 0. So let's find it. So y equals -4 times 0 squared minus 24 times 0 minus 32. Here we'll get a 0. 0 times any quantity is 0. And again 0. So the first two terms 0 out, leaving a -32. So in went 0 for x and the output is -32. That is our y-intercept. So for part D, we'll go ahead and record that. Y-intercept 0, -32. Now let's find our x-intercepts. This time we're going to let y equal 0. We're going to undistribute a -4, and that is to say to factor out a -4 from each of the 3 terms. Bring down 0 equals, and we're left with this trinomial. X squared plus 6x plus 8. And we factor x times x, factors of 8. 1 times 8, 2 times 4. And then we look at our sign rules for factoring. This sign on the constant term tells us 2 things. It's a plus, so the factors that I choose will add to 6x. Again, it's a plus, and it will tell me that the signs will be the same. Same could mean subtractions in each of the binomial, or it could mean 2 additions in each of the binomials. So we look to the middle term to determine how it's going to be the same. That plus means I'm going to have plus symbols in my binomials. My choices, the only choice out front is x and x. And which of these pairs add to 6? That would be 2 and 4. And then just a little record keeping, recording everything that we had before. And so the zero product property says I can, if I have 3 factors multiplied together to equal 0, one of those factors or more or all had to be 0. This number offers no information about x. There's no x attached. I can try to set it equal to 0. I see that it's not equal to 0. I set the other factors equal to 0 and solve for x. I get x is -2 or x is -4. So I plugged in y as 0 and I found the corresponding x values, -2 and -4. Those are my 2 x-intercepts. So on section E, I can go ahead and record that. My 2 x-intercepts, -2, 0 and -4, 0. Now we have enough information to graph. So let's zoom in here and actually graph. So starting with our vertex, -3, 4. We graph that vertex. -3, 4. And the vertex sits on the vertical axis of symmetry. So we sketch in our vertical axis of symmetry. And we have our y-intercept, 0, -32. That's beyond this 10 by 10 coordinate system. We also have our 2 x-intercepts. And that's enough information to sketch a graph. We want to draw a smooth curve of our parabola. Finally, we want to determine the domain and range. So, domain deals with the x values, and range deals with the y values. So as we look over the x-axis, the graph exists everywhere, looking across. Because this will, I'm going to exaggerate the effect. It's going to keep going down and over and over and over to the right as x gets smaller and smaller. And the same thing happens here. Just keeps going very slowly over to the right. So this is the left and the right. So it goes from -infinity to +infinity. So that is our domain, from -infinity to +infinity. And now for the range. That involves the y values. What's happening to the graph of f as we travel further down on the y-axis in the negative direction and upwards on the y-axis in the positive direction. So we always start from the bottom. And we notice that this graph is going to keep going downward on both ends. So that's coming up from -infinity. When we move up the y-axis, it stops right here at 4. The graph does not go above positive 4. So we're going to stop it at 4, and we're going to include 4. So there you have it. We have graphed this quadratic function, and we've named the domain and range.